So this unit is going to be all about fractions, specifically algebraic fractions. Now, you guys have done numerical fractions, like in middle school, where you learn how to reduce them, you learn how to add them, subtract them, multiply them, and divide them, okay? That is a type of rational expression, but it's not the ones that I'm talking about, okay? We're talking about fractions that have variables in them, which you have done a little bit of, okay? Back when you did fraction equations in grade 9, those were actually algebraic fractions you were working with. Okay, so for my purpose here, a rational expression, whenever you see the word rational, think fraction. So a rational expression is an algebraic fraction, I'll call it. I'm not going to deal with numerical ones. Where the numerator and denominator are polynomials. We learned the word polynomials back in grade 9. A polynomial is simply an algebraic expression that contains one or more terms, but it has to meet certain conditions. If it's got exponents in it, they can't be negative exponents. They can't be fraction exponents. They got to be whole number exponents. Okay. So all the ones that all the algebraic fractions we're going to be looking at, they are all polynomials in the numerator. So, for example, very simple one, 1 over x. Okay, 1 is a polynomial. Doesn't necessarily have to have a variable. 3x minus 9 over x squared minus x minus 30. It'd be as complicated as that. Okay. Numerical fractions are examples of rational expressions, but we're not going to focus on those. Okay. Now, when we have variables in the numerator and or the denominator, there's something extra we've got to do, especially when there's variables in the denominator. Okay. So if I give you this, if I give you this very simple one. If I asked you if x is 5, what's the value of this? Don't overthink. 1/5. If x is -1, what's the value of this? 1 divided -1 is -1. If x is 0, what's the value of this? Undefined. So I can plug any number I want in as long as it's not 0. If the denominator becomes 0, that means it's undefined. So those values of x that would make a denominator 0, we call those non-permissible values. They're not allowed, they're not permitted. Okay? Or, just to save a little bit of time, I always call them NPVs. Safe. Instead of writing that word out. So, the non-permissible values are values of a variable in a rational expression that make the denominators equal 0. That make the denominator equal 0. So for rational expressions, well, obviously, this means the denominators cannot equal 0. And if they do, well, the rational expression is undefined. So what we're going to look at to start with before we actually start reducing these things and adding them and subtracting and multiplying and dividing is finding non-permissible values. So if you look at this first rational expression, what value of x would make the whole denominator work out to 0? Don't overthink.
0.
0, because 3 times 0 is 0. So you can state it one of two ways. We can state the NPV equals 0, or you don't have to do it both ways. You can say x not equal to 0. You can state it one of those two ways, but don't go NPV not equal to 0, because that doesn't make any sense. The second one being, well, we've got a couple of variables in it, and it's in factored form. Well, we know how to solve, or we know how to find values of variables when it's in factored form. Set each factor equal to 0. So what value of x would make this factor 0? 0. What factor of x would make this factor 0? Right, so you have to solve it. I think you guys have sort of seen the pattern. So I'm not going to start writing all this. I'm not going to write all the steps. So that means that the NPVs for this one are 0 and 3/2. Or you can say x not equal to 0 and 3/2. I'm not going to keep writing both of them. So if it's in factored form, it's pretty easy to pick up the NPVs. What's the problem with this one? C. Who cares? Numerator doesn't matter. Numerator can be 0. It's okay. We're only looking at the denominators. I want to figure out what values of x make this equal to 0. Well, is that a quadratic equation? So don't I factor it? So factor, and then set each factor equal to 0. And those are your NPVs. So I don't have to worry about the top, unless reducing it. Let's talk about that later. What we got? Now you don't have to show the additional work. You can just go straight to the NPVs. What value of x makes this 0? Maybe a 2. What value of x makes this 0? Positive 3, and there we go. Or again, you could say x not equal to -2 or 3. Either one is fine. How about D? Sometimes if it looks easy, it is. What's that? What's the problem here? There's no variable in the denominator. It's just 8, which means there are no NPVs. If there's no variable in the denominator, you can't have any non-permissible values. Okay. So that's non-permissible values, something to keep in mind as we work with reducing and then performing the 4 operations on it. Okay? Before we start looking at the operations, we're going to start looking at reducing or simplifying. So let's go back to middle school. How would you notice this is a rational expression? It just doesn't have any variables in it. How would you reduce it? Yeah. Okay, I can divide by 3, I can divide by 3, and I get 4 over 5. Easy. Or you can look at it like this. I can divide by 3, so cancel out the 12, and it's replaced with 4. Cancel out the 5, or sorry, the 15, and it's replaced with 5. Actually, better to look at it that way. Apply this to this, but before we reduce, we have to state the non-permissible values. We got 2 variables. What can't x be? 0. What about y? So we could say x not equal to 0, y not equal to 0. Or NPVs for x and y. Now let's reduce. Well, look, how many x's can I take out? I got an x cubed up here and an x squared down here. I can take out 2, right? Which will leave me with just 1 there, right? Because x squared divided x squared is 1. What's x cubed divided x squared? X cubed divided x squared. X. It's just x. So there's an x left here. Now I can reduce the y's. What's the maximum number of y's I can divide?
1.
Right, so y divided y is 1. Y to the 4th divided y is y to the 3rd. Y to the 4th divided y is the same as y to the 4th divided y to the 1st. So I've got x times 1, x, and on the bottom I've got 1 times y to the 3rd, y to the 3rd. We're done. With a lot of them, before I reduce, I'm going to have to factor. Because right now, like you cannot, like why can you not cancel the x's out of those 2? I keep explaining this over and over again, but some of you just want to break the laws of math and do it because it just looks so tempting, I guess. Or you look at 4 and 8, that can go. Or 4 and 6. Why can't I do that? No clue what you said. Again?
It's not moral. Because
Remember, when we've got fractions like this, you have to assume there's parentheses around, which means these 2 are together. You cannot pull one of them out to cancel with something else. The whole thing has to be canceled together. The only way I can cancel this if there's an identical one on the bottom. The only way I can cancel this, if there's an identical one up top. Not part of it, the whole thing. So just keep that in mind. Because students do have some trouble sometimes. So what we've got to do is we've got to factor top and bottom. Because we're not just looking for NPVs, we're looking for identical expressions to cancel. What kind of factoring is up top? Simplest kind of factoring. GCF, what can I take out? I can take out an X. What am I left with? 4x plus 3. Bottom. GCF again, and I'm left with. Now I've got identical expressions, but don't cancel yet. State the NPVs. Because if you state the NPVs at the end, you're going to miss them. You have to state NPVs before reducing. Well, this won't have any NPV because it's not a variable. What value of x makes this 0? -3/4. So NPV equals -3/4. Now go nuts.
That's my recommendation.
Okay. The next one, you should be able to look at the top and bottom and say those can be factored. But it's different types of factoring for each. What can I do to the top? GCF, right? What does it look like when I factor? 3x minus 2. I want you guys to try and do the bottom one. That's one of those AX squareds. So that's where you got to kind of do the logical guess and check. So we're going to break it up into 2. And then you got to fit the variables and the numbers in so that if I were to multiply these, I'd get this. I'll give you a second to do that on your own before I jump in. Anybody got it? X plus 5, x subtract 2. So 2x times x is 2x squared. 5 times -2 is -10. Then if I do the rainbow, I get -4x, positive 5x, which together make positive x. Excellent. Remember, NPVs next. What can't x be? -5/2 and 2. Now cancel whatever you can. These each cancel down to 1. I'm just not going to write the 1. And we're left with 3 over, and you can put the parentheses or not. Like a lot of times I will put, when I see a question like this, I'm going to do this right away just to remind myself, you know, they have to be identical to cancel up top and the bottom. There's nothing identical between these two. Okay, the last example is kind of a special case. Like, what do you notice? Same terms, subtraction, but it's reversed, right? Okay. What if I gave you what if
What if I gave you this?
What do you think that would cancel to? I'm not gonna worry about the NPVs for this one, right? What do you think that would cancel to? Why? You said 1, right?
Yeah.
You're correct.
Because the values are the same.
Yeah, like is B plus 3 and 3 plus B the same?
Yeah,
Yes.
but it's.
If it's plus, the order doesn't matter.
That's it.
But if it's minus, the order matters. Okay, so this one would cancel to 1, but this one
Would not cancel to 1 because they're not identical.
but it will cancel to a number. First of all, well, let's state the NPVs. What can it be? D? 3. So what I'm going to do first is I am going to rewrite the bottom.
So that it's in the same order.
3 minus B is the same as negative B plus 3. So you can see that
They're not the same.
oh, man. I can actually factor the bottom. I can factor out a negative 1. If I divide each of these by negative 1 or factor out by negative 1, what am I left with? This divide negative 1 is B subtract 3. Notice that when I did that,
I got identicals.
but I got identicals with a minus 1 at the bottom. Remember, this reduces to 1, so 1 divide negative 1.
So if they're reversed and plus, if they're identical, they reduce to 1. If they're reversed but subtraction, in same terms, they reduce to negative 1.
So you don't have to show all that work. Best thing you can do is just sort of like, I'll give you something like this. And you're like, oh yeah, that's one of those ones where it reduces to negative 1. You can just do that.
You don't have to show all the work.
Okay? I prefer that you not show all the work.
I'm just showing you why it's negative.
Okay, that's it.